Now we're talking about conflicting signals in capital budgeting. And this is where two projects that are mutually exclusive, they're both acceptable to you. But you do the analysis, net present value tells you to take one project, internal rate of return tells you to take a separate project. As you saw in the previous video, when you plot the NPV profiles, they cross. And where they cross is called the indifference point. Now the indifference point is the rate of return, the interest rate that sets the net present value of one project equal to the net present value of the other project. So that's what we're looking for here. We're looking for the indifference point. And if you wanted to calculate the net present value of project A, you take the present value of the inflows. In this project, you got $3,000 a year for 15 years. You multiply your annuity times your PVIFA with N equal to 15. That would give you the present value of your inflows. Subtract off the cost of the project, the initial investment, and that would be the net present value of project A. Project B, very similar. We take its cash flow each year, $20,000, multiply it by our PVIFA with N equal to 15, I equal to something. That would give you the present value of the inflows. Subtract its cost, $95,000. That would be the net present value of project B. Now, if we take this equation and simplify it, combine like terms and like, what you end up with is $83,000 equaling 17,000 times our PVIFA with N equal to 15 and I equal to something. And in the notes I gave you, I showed you how you interpolate this, if that's what you want to do, if you want to work it by hand. Most of us would use a calculator. And what this is really telling us is that, do we want to spend an extra $83,000 now in order to get $17,000 more every year for 15 years? Well, set present value equal to a negative $83,000. That's the additional cost. Payment is the additional cash inflow, which is $17,000. And you're going to get this additional cash inflow every year for 15 years, so N is 15. Have your calculator solve for I, and you get 18.9688%. Now that's the indifference point. That's the interest rate that sets the net present value of project A equal to the net present value of project B. In a decision-making mode, though, that's what I need to compare to my weighted average cost of capital. So if the weighted average cost of capital is less than the indifference point, we choose based on net present value. So in this problem, in this example that I gave you, we choose project B. If the weighted average cost of capital for some reason was greater than this, then we'd have chosen between the projects based on internal rate of return. And if that would have been the case, we would have chosen project A. So again, this is known as the indifference point, and the indifference point is the interest rate that sets the net present value of one project equal to the net present value of the other project. And this is how you choose between projects when you have conflicting signals.